Yosh Buttler and David Warner sit on a park bench, reminiscing about their childhood. I miss being a kid, David Warner sighed. Life was so simple. Yosh Buttler smirked and picked up a small rubber ball lying near his feet. Simple like this? He tossed it toward David Warner, who instinctively caught it. Oh, you're on, David Warner grinned, getting ready for some fun. What started as a casual throw turned into a full-fledged game of catch.
So now this game of caught and receive resulted in making a parabolic path. A parabola whose vertex is lying on the origin with equation x square is equals to minus 4y and a normal drawn across the parabola. Let's have a look at the question. It says the slope of chord of the parabola this. It says normal at one end which subtends a right angle at the origin. So let's draw a right angle at the origin. So the two ends of the parabola when joined with the origin, it subtends a right angle with coordinates of the 2 points 2t1 comma minus t1 square and minus 2t2 minus t1 square. Let's name it A and let's name it B and the origin O. Now let's write the equation x square equals to minus 4y and let's differentiate on both sides, and upon differentiating we get that the slope of the tangent is minus x by 2. That means that the slope of normal will be 2 upon x. That's 1 upon t1 according to the coordinates of P. Now let's move on to the next page, and what we can see that slope of AB according to the formula y2 minus y1 upon x2 minus x1 will result in minus t1 square plus t2 square upon 2t1 plus 2t2. Factorizing the numerator part, we will get t2 minus t1 into t2 plus t1, and below we get 2t1 plus t2. This will get cancelled out and we are left with t2 minus t1 upon 2. This is actually the slope of the normal, and since the slope of normal will be equal to the slope of AB line, it means that t2 minus t1 upon 2, what we got, is equals to 1 upon t1. Upon simplifying this equation, we will get t2 minus t1 square is equals to 2. Let's name it equation 1. Let's calculate slope of OA. It will be by the formula y2 minus y1 upon x2 minus x1, get t2 upon 2. Similarly, slope of OB. Again, applying the formula, we will get minus t1 upon 2. And since we know that this AO and OB are intersecting at a right angle, so their slopes, the product of their slopes will be equal to minus 1. And now placing the values of slope of OA and OB, we'll get T1 into T2 is equals to 4. Now placing this value of T1, T2 in equation 1, we can write 4 minus T1 square is equals to 2. It means T1 square equal to 2. That will result into two values of T1, that is plus minus root 2. But since T1, the coordinates lying at the positive x-axis side, so T1 must be positive, hence T1 is root 2. But since the slope of the normal is 1 by T1, it will result into 1 upon root 2.